Hello, in this video let's discuss third question of today's contest. You are given a positive integer n. For every integer x from 1 to n, we write down the integer obtained by removing all the zeros from the decimal representation of x. Return integer denoting the number of distinct integers written down. N is up to 115. For example, if n is equal to 10, then write all the numbers from 1 to 10 by removing zeros. So 0 will be removed only from 10, so it will be indirectly 1, which we already wrote down before. So the total count is only 9. If the number is 3, all 3 have no zeros, so they all 3 will come and the answer is 3. So for example, if the number is 12, then what is the answer? So all numbers from 1 to 9 are distinct and they have no zeros, so all 9 will come, so answer plus is equal to 9. And then coming to 10, we have 10, so by removing this we will get to 1, which is already there, so no increase of anything. 11, new one, 12, a new one. So the total answer is 11 if the number is 12. So from this we can easily understand that we can start through lengthwise, because for example, if we have number with 5 digits, then firstly we can count the number of integers in of length 1, of length 2, of length 3, of length 4 and 5. Because why are we sure that we have to come from smaller? Because we have to count all the integers less than or equal to some number. So if the number has 5 digits, every number with only 2 digits obviously less than this one. So we are sure that we have to include this. So as we have to include this, then we can start from lengthwise, so that it will contain all the possible options. So now let's come to length 1. So coming to length 1, now the next thing is, when we are at length, we want the number of integers without 0, right? Because let's say we got some 103. So when we are considering 103, what it means? It means that we already considered the numbers with 2 digits and 1 digit also, because we start from smaller digits, right? So whenever we are considering 103, it is useless, because 0 is we should not consider, and the number is 13. So this will surely contain less digits than this, right? These may have any number of zeros. For example, if the number may be 100340, even if this is the number, then we no need to include zeros. So finally the number will be 134. So when we are doing the iteration for the numbers with 6 digits, the numbers with 3 digits is already done. We already counted this distinct number when we are considering the answer for digit 3, right? So no need to count this anymore in 6 digits. So now what we want? So simply now what we want is, when we are at length L, we want the number of integers without 0 in decimal representation, because they are already included in the previous answers when we are considering the answer related to lower digit numbers. So finally, let's say we have 10034, right? We have 10034, and we reached this. How we reached this? We reached this by traversing the all numbers from 1 to 10, 1 to 9, 10 to 99, 100 to 99, and so on. So when we are reaching this, we already considered the answer for smaller digits, so no need to count this anymore. So now we want how many digits without 0. So length 1, what is the answer? It is simply 9 bar 1, because we only have 1 digit to select. We don't need 0, so simply 9. And now coming to length 2. So how many numbers of digit length 2 have no zeros in it? So simply here the choice is 9, and here also the choice is 9, because we don't want 0 anywhere. So we only have options from 1 to 9. And how many digits we can keep? We have 2, so it is simply 9 into 9. And coming to 3, so even now it is same for 3. So we have 3 choices, and anywhere we no need to keep 0. So now what? 9 into 9 into 9, which is 7 to 9. So in this way, when given a length, we want the answer without zeros. And now let's think about the answer. So for example, if the given number is this one, 6928292, now we have to find the answer. What is the answer? We have to write all the numbers from 1 to this, and we have to find the distinct numbers without zeros. Right? So what is the digit count in this? It is simply 1 2 3 4 5 6 7. So the digit length is 7. So let's start from 1. Let's start from 2 3 4 5 6 and 7. So coming to 1, what are the number of digits? What are the number of count that will contribute to answer? It is simply 9, because any of those do not have 0. And coming to second range, 10 to 99. So coming to 10 to 99, Even now we discussed that the answer is 909, because there will be some numbers with 0, like 10, 20, 30, and so on. So this should be excluded, right? So simply we can count only numbers without 0, simply 909. And for 3 digit it is 9 cube, for 4 it is 9 power 4, and so on. So now we reach to 6 digit. So even every 6 digit number is also less than the number with 7 digits, right? So even for 6 we will add 9 power 6. And coming to 7, now we can't do that, because the count of 7 will include 9, 9, all 9, 7 times also. But this is more than the number we want. But we only want the numbers from 1 to n, right? So this logic will work fine till digits which is equal to the initial size minus 1. Because when we reach initial size is equal to the iteration we are at, it means that all the numbers are not smaller, not larger than the given number. That maybe they can be larger than the given number, which will contradict. So now we cannot simply do that. Now what can we do? So we got all the answers till digit length before this one. But what about equal to length this one? Even they will contribute to answer, right? So now, even now it is very simple. Let's say we want 10, this is what 10 power 7. So now we counted all the answers from 1 to 9, 999 6 times, and now we are trying to find the answer from 10 power 7 to 67 something, right? So firstly, if we start from 1, so let's start from this digit. So the first digit is right, so we can keep 1 here, we can keep 2, 3, 4, 5. So if we keep all this, it means that even then we can keep any digits here, right? Because now our main goal is to make sure that the numbers are less than or equal to given number we have. So we are trying to reduce layer wise. So initially till now what we done, we reduced one digit itself, right? So if the digit is 7, we started counting from 1, 2 and 6. 1, 2, 3, 4, 5 and 6. So we indirectly removed 10, 10, 10 division by 10 numbers. But now when we reach digit 7, so even now we can try to reduce digit wise, right? So initially we have 692, 982. So we have this, right? So now let's start with this. So when we are starting with this, what if we try to start with 1 here? So if we try to start 1 here, we can keep 1 to 9, 1 to 9, 1 to 9, 1 to 9. We can keep any digit, right? Any digit right here, because there is already an integer less than the given integer in the higher MSB. So any number if we write after, it is independent. This will be surely less than the given number which we want, right? So now, even now, after this is the final string, this is the given string. So we will start from index 0, like index MSB, and then we will try to choose the numbers from 1 to the digit minus 1, because here we can place 1, we can place any number from 9 to 9 in all of these positions. Similarly for 2, similarly for 3, similarly for 4, and similarly for 5, because 5999 is also less than 6, this big number, right? So now let's come to 6. So if we come to 6, we can't blindly write all 9. Why? Because this number is matching, right? This number is matching, so there should be an integer which should be max is equal to this number, right? So now we can't blindly write 9. So now what can we do? So even now we can try same formula. What? So now this is the main position, right? Because till here it is 6. So can we write 7 here? No, we can't write 7, because this will exceed the given number. And now let's come to this. So if we come to this, the digit here is 9, right? So we can place 1, we can place 2, we can place 3. So if we place 1, this can be 9, this can be 9, this can be 9, and so on. So in this way, we are trying to use the digits with less than digit, which is actually here, and we are trying to place all the numbers, because even now the main goal is to find the numbers without zeros. So if we have three choices, we will have 9 into 9 into 9 choices without zeros, right? So that is why given a digit, so let's say we are at digit 3. So digit 3, we will have two choices, 1, 2. And what we'll do, so if we keep 1 at all the remaining positions after this, we have 9, 9, 9, 9, 9 choices, because we don't want 0. So simply 1 to 9, there are 9 choices for every integer, like every bit here. So even for 2 it is the same, 9, 9, 9, and we can have all those 9. And now if we came to 3, so if we came to 3, we cannot do that. Why? Because we are not sure that if that will exceed the given number or not. So now what we have to do again, so now let's come to this digit. So if this is 2, so now we will start from 1, right? So we'll start from 1. Let's say this is 3 again. So this is 3. So we'll come to 1. Again 999. We can try all positions. And if you observe, any of these two are not overlapping because the digit itself is overlapping. So even if there are 9s here, these both are different, so numbers are different. So we are counting uniquely only. And now we'll come to 2 also. We'll keep all 9s. And then if we come to 3 again, again we cannot blindly keep 9s because this match till now. What if the number is 1? If we keep 9 here, then that is wrong, right? So now if the number is 1, then we can keep only 1. And we'll try to think about next position later. And if the next number is 2, we'll keep 1 here and we'll try all the 9s and we'll add to that answer. And we came to 2 again, so we cannot blindly into 9s. And then we'll go to the next integer. So now we will go to 1, we will go to 2 till the digit ends on. So we are trying to remove layer by layer and we are able to get the answer, right? So in this way we can find the answer. So let's check the other case also. What if the number is like 1009? So now what we have to count? We have to count 1000 to this because all numbers from 1 to 999 are already included when we are thinking about smaller digits. So if this is the case, then what will be the answer? Then also we will try to do the same. So firstly let's come with 1. So we came to 1. So there is no other option to keep here before 1, non-zero, right? So this is simply 1. And we came to 0. So if we came to 0, what it means? So what it means? It means that this number is useless because 1009 is already added as 19 in the previous positions, right? So it means that there is no need to check other because all the numbers in between these are already included in the past. So simply break the loop. So no need to add any answer. Why? Because when we reach any 0, for example, if we are reaching 0, so this is indirectly 19, which is already included in 1 to 99, right? So why are we wasting our time here? So simply if we reach any 0, break. If we reach any other number, then start looping from 1 to that number. And if the number is less than that, so include 9 power remaining plus and all. And if we reach the final one, then again go into next digit and start from 1 to that and so on. Let's check the code. So simply we are converting this to string and then find the number of count and the answer is 0. The power is simply 9 because for 1 to 9, what is the count of digits without 0? It is 9. From 10 to 99, it is 9 into 9, right? Because we have extra digit from above. So this is 1 digit and we have other digit also. So into 9. So when we are at ith digit, the answer is simply I minus 1 digit into 9. So we can simply store a variable power which is the answer for latest one. So that when we are considering the present one, we can simply 9 into do that and we can get it. So do all the digits for less count than present one. So 1 to less than the size, right? So now increment in the answer, multiply with the 9 so that it will be useful for the next set of digits. And then we found the answer for all the numbers from with less digit. If the number is 5 digits, we found the answer till 4 digits. Now the main goal is to find the number of numbers with 5 digits that are less than or equal to that given number and it will have no 0. So now start through all the digits and now come through digit wise now. Here we did not consider any x of I because in only digit is matter. But here we want the digit also. So into digit is equal to the ith number and then we have to loop through all the numbers less than this digit. Why we are not doing this is equal to digit? Because that will be indirectly counted, right? For example, let's say 3, 2, 4. So now we are at 3. So in the loop we are only considering 1, 2. So when we are considering 1 and 2, if this is completed, so now we will go to 3. So when we go to 3, this will not continue. Like 1 to 2 this is completed, so we added. So we came to this loop again. So now we are thinking about 3. So it means that this number is completed. So we indirectly came to this. What it means? It means that we already hard coded 3 for the answer right now, right? So find the present digit and loop through all the digits less than that. So 1 to less than digit. And now the next thing is, let's say we have 3 to 4. And now we are at this digit and we are at 1. So if we are at 1, what is the answer here? So how many places we can keep 9? We can keep 9 in the remaining positions. And what is the remaining count? So total length minus I minus 1, right? So these are the remaining digits, and in each of the remaining digits we can keep 9. So simply find the number of remaining digits and do 9 power of that. So remaining is size minus I minus 1, and then total base is equal to 9 power remaining, and then loop is completed. And then we discussed, right, if the digit is 0, it means that no need to count the answer, break the loop. So simply break the loop, no need to count any answer. And now if we reach the final digit, it means that we got this also, right? Because in this type of DFS, in this type of thing, we are not considering the equal to number. So finally when we are reaching the I plus 1, size minus 1, we can simply increment the answer, and finally return total. In this way we can find the answer. If you have any doubt, comment below. See you in the next video.